Alright, this is some practice calculating a dot product. Just to remind you, we have two ways to calculate the dot product. We could take the magnitude of A times the magnitude of B times the cosine of the angle that's in between them, or we can do it in component form, where we multiply the x components, multiply the y components, multiply the z components, and then go ahead and add those guys together. Consider this vector A. It's got some positive x and some positive y. It's going to come up off the positive x-axis kind of like this. And this vector B, where I have positive x and negative y, is going to be below the y-axis. So I've kind of sketched these guys out. Because I've given you these guys in component form, probably the easiest way to take the dot product is to go ahead and use the latter of the two. I'm going to take my a sub x, that's going to be 3, and I'm going to multiply that by b sub x, that's going to be 7. I'm going to go ahead and do the same thing with the y components. The x, or the a, is 4, and the b is going to be negative 2. And you go ahead and you type that all into your calculator, and you're going to get a nice value of 13. Let's go ahead and figure out what this guy is doing it the other way. We know that this is going to probably be a 3, 4, 5 triangle, so the magnitude of a is probably going to be 5, and we can go ahead and do the Pythagorean theorem and convince ourselves that the magnitude of b is going to be roughly 7.28. Again, that's just going to be 7 squared plus 2 squared, take the square root of it. Now we know the magnitude of a, we know the magnitude of b. Let's figure out the cosine of the angle in between them. You're going to go ahead and probably take the inverse tangent of the y side, that's going to be 4. I'm going to go ahead and do the 3 side, and I've got my inverse sign, and it's going to work itself out to be 53.13 degrees. You go ahead and do something very similar, and you're going to find out that this is roughly 15.95 degrees. So the angle that is going to be in between A and B in this case is going to be the sum of those two, which is going to be 69.1 degrees. Now we're going to say, okay, what is A dotted with B? Well, that's going to be the magnitude of A times the magnitude of B, 7.28. Put some parentheses around that. And then cosine of 69.1, and you're going to get roughly 13 with rounding and sig figs. Let's just do another calculation. Now I have an xyz vector and an xyz vector. You can do this one using the angle method, but figuring out that angle is, well, more difficult than I want to do. So we're just going to go ahead and do the second method. We're going to take the x components. For the a, that's going to be 3. For the b, that's going to be 7. We're going to go ahead and do the y components. For the a, it's going to be 4, and this is going to be negative 2. And then lastly, we do the k components. For the a, it's 5, and for the b, it's going to be 1. And you type all this into your calculator. When we do it this time, we're going to get a value of 18. Note that this is a scalar. It does not have any direction associated with it, so it's just flat out 18. Let's now go ahead and calculate the vector product using the same two vectors, where I still have the same vectors a and b that I did on the previous example, and I know their magnitudes and the angle in between them. So for the vector product, we have two ways to do it. We could figure out the magnitude using a times b times the sine of the angle between them, and then use the right-hand rule to figure out the direction. So for that one, what we're going to do is we're going to say a crossed into b is going to be the magnitude of a, which we know from before was 5. We know that the magnitude of b was 7.28, and now it's not going to be the cosine, but the sine of 69.1 degrees. And we type this in, and we're going to get a value of roughly 34. Now we don't just write 34, we have a direction we need to worry about. So we're going to take our fingers, we're going to point them in the direction of A. We're going to curl them through the smallest possible angle into B, and what's going to happen is the direction of your thumb points into the page. So what this is this is going to be the negative k hat direction. We can also use this expression right down here to figure out the x, y, and z components of the cross product, and it's pretty straightforward. This one we don't have any value for that. We don't have any value for that, so there's not going to be anything in the I direction, as we would kind of expect. The same is true for this guy right here. Both of those guys are 0, and all we're going to have is these components right here. So what we can do is we can say a crossed into b is going to be a sub x, which is going to be 3, b sub y, which is going to be negative 2, we have a minus sign right here. Now we have a sub y. That's going to be 4 multiplied by b sub x. B sub x is 7. And lo and behold, we get the same exact number within rounding. And we have to go ahead and put the direction on there. So there we get my k hat. Last but not least, let's do one more example. Now I have an xyz vector and an xyz vector. And for this one, it's quite difficult to figure out the angle. So we're going to go with the equation 1.26. So what we can do is we can say a crossed into b is first going to be a sub y. A sub y is going to be 4. B sub z is going to be 1. That's this guy right over here. Minus a sub z. A sub z is equal to 5. B sub y is negative 2. So put that guy in right here. And we need to put an I hat on there. And we can go ahead and do the j component. That's going to be a sub z. A sub z is equal to 5. B sub x is equal to 7. Then we're going to minus a sub x. A sub x is equal to 3. B sub z is equal to 1. And we need to go ahead and put a j hat on here. Last but not least, we need to do our k hat vector. So we're going to have a sub x. That's going to be 3. B sub y is negative 2. And then a sub y, followed by b sub x, negative 2. And this is going to be k hat. So let's type all this in. What we end up with is a crossed into b is equal to 14 I hat plus 32 j hat plus 2k hat.